I'm going to show you that the frictional force between two surfaces depends on the normal force. So imagine that I have a block right here and I have friction pushing it forward like I would with these tires and gravity pulls down. How can I increase the frictional force? Well, you could definitely change this coefficient of friction and make it a different kind of material, or you could push the two things down together. So let's just do this demo. I have this little buggy. It's got rear wheel drive tires here, and I'm pulling this sled. Let's see what happens when I turn it on. So the frictional force on the sled is too large. And so we cannot generate enough friction between the tires and the road to pull it forward. Well, how can we fix that? I'm going to show you one way to do that. Here is an extra 500-gram bar. Is that a 500? I don't know if that's 500 or 1,000. I think that's 500. So if I add this on top, then it goes. Now, of course, the other way I could make it go is to remove the friction. I didn't remove the friction. What I did was I decreased the mass of the block so there's less friction on this. And then there's a tension force between these two. This would be a great example to draw a free body diagram for both the block and the car in the case where the block doesn't move and then when it does move. Remember though, the key thing, the static friction force is less than or equal to this value, right? So it's not going to, if I have too much friction, it doesn't move because there's too much friction. It doesn't move because there's exactly the same amount of friction that's pulling it forward, and the net force and the X direction 0. Good demo. Talk to you later. Bye.